busy,
Okay.
but Schnooks does bring a steady round of projects still.
Okay, that's awesome. Yeah, they recently acquired so many new stores, and that's very big for them.
Yep. Okay, we are right at noon. Should we get going?
Yep, go right ahead.
Okay. So good morning to all of you. Um, it's a pleasure to welcome you to our Lunch and Learn event. My name is Seetu Sita Raman. I'm a professor of marketing at the Olin Business School at WashU, and I head or direct CABI, the Center for Analytics and Business Insights, and Katie Kennedy is program manager at CABI. Now, Lunch and Learn is one of different types of things that we do by way of interfacing industry with academics. So we also run industry practicum projects where companies bring real-time business problems, which our master students who are trained in business analytics are tasked to solve. So these work as semester-long experiential engagements. And we also run what are called immersion training courses on technical topics, usually pertaining to AI and machine learning, as applied to, again, solving business problems. So some of you, have consumed our events before. Some of you may be first timers, which is why I thought I'd give you a bird's eye view before we get going. I let today's speaker introduce himself, but it gives me great pleasure to welcome Yao Shepherd, who used to be at Schnooks and used to work in a variety of roles, bringing these kind of experiential projects that I just mentioned to our students and so on. So he and Katie go back quite a few years. So now in his current role, he has come back to share some of his insights in, letting analytics drive what he does. I let him tell you a little bit more about himself before he dives into his talk. So let me just briefly mention that Yao is a proud WashU alum. He got his PhD in, was it math and CS?
Math,
Yao?
just math.
Just math. Um, and, as I said, he has collaborated with us, and we are always grateful to people like him who connect with us to keep us on the straight and narrow in terms of training our students to address things that bring value to organizations. So it's a give and take. We learn from them, they learn from us. With that, I'll hand over to Yao. Welcome. Take it away.
Thank you. Thank you, for C2. So really enjoyed working with C2 when I was at Chinooks. We were working on some very interesting projects together. Again, really appreciate the opportunity and the invitation to kind of give a talk here. So I have a lot of connections to WashU. So I came to St. Louis in 2009, had PhD in math, graduated in 2014, then stayed in St. Louis since then. Um, and I am currently actually taking an MBA. I'm graduating in May next year. Hopefully, I can graduate in May next year. And a lot of connections. I run in my current startup. All the kind of founders are from WashU. Um, and have had a lot of opportunities to work with students from WashU and so on. So it's really a lot of connections. So a little bit more about myself is that I had PhD. After I had PhD, I spent over 10 years across industries. I was uh, worked at Monsanto, back Monsanto, Bayer, MasterCard. I was director of science at MasterCard, director of science at Chinooks for about 3 years. And I have a separate data science and AI consulting firm that I ran for a couple of years. So right now I'm running a venture VC-backed startup called Assertion AI. So I'm the founder and CEO of Assertion AI. And then so Assertion AI is backed by industry leader, Allen Institute for AI. They're incubator. So Allen Institute for AI is founded by Microsoft co-founder Paul Allen. They're based in Seattle. So we're backed by them, and they invested in us. We co-developed some product. I'll talk a little more towards the end of the talk. Yeah. So very happy to be here to share. Let me start to share my screen. I do want to make sure that it's a little bit more interactive. I don't think I can see anyone, but if you have questions, feel free to just ask or just put in the chat so that I can actually know a little more about what you're thinking, and also I can tailor the talk a little bit more. Yeah. All right, let me share my screen. Okay, can you see it? Okay, slides looking fine? Okay, all right. So my title is AI that works, turning it into real business impact. So as I just mentioned, I've spent over a decade working on data science. Basically, my entire career has been on data science, and I worked across industries. My thesis was on have a co-advisor from computer science department working on a healthcare problem, which is actually radiation therapy problem, and spent a lot of years in agriculture, in financial services, MasterCard, and then retail. In my consulting firm, we served more kind of a clients across industries. It's really like I've been seeing this how AI is being used across industries, and what are the common mistakes everyone's making, and really how can we, is there a formula, and what would be the formula if there is one to actually turn data into actual impact? So I'll talk about, let me share so here's the outline. We'll talk about AI hype gap. Well, working AI really means data as your advantage, from models to decisions, proving ROI early, deploying AI that sticks, real world wins, and you apply the AI roadmap, the future of practical AI. So when you see this list, you're going to see that, okay, so this doesn't make sense. This sounds like generated by ChatGPT, right? So yes, it was generated by ChatGPT. And that's why I'm not going to talk about it. If you're interested, you can actually just ask any large language model, okay, so this is a topic, give me an outline. And this will be like typical outline that it will give you. Will makes a lot of sense, but it's just not deep enough. And then, so when I work across companies, industries, because of my training and background as a math, right? So we're always trying to identify the essential part of a problem. It's like, okay, we need to look at things in a very simple way. I need to see that. I need to know the bottom of the bottom of a problem. So that's really what we're trying to. That's my kind of basically mental kind of thought process, if you call that. It's also the outcome of the training is good, both good and bad. But that's how I'm seeing all this in a try to try to look at all this from a foundational perspective. So instead of going through this, and then you can actually interact with any language model out there, you can get a very decent answer for each of the outline that's listed here. So so I'm not going to talk about that. So I'll try to bring I'll try to talk through two frameworks that actually helped me understand how to bring value from AI to the organization, no matter what organization it is, what industry you are in, how large the company is, and so they should be all useful. Okay, let's go ahead, get started. So starting from a question, what is AI? I want to ask the room and see if anyone can kind of be a little bit more interactive. Anyone can share like what's your thoughts? What is AI?
I can give you a
Okay.
hi. I would probably say my definition of AI, it's kind of like a predictive generation model that
Okay.
tries to predict based on various factors and training data solutions based on questions.
Okay. Yeah, that's great. That's great answer. Yeah, so different people have different opinions, kind of definitions on AI, and then some think it's broader, some think it's narrower, some think AI is just is the same as data science, some doesn't think so, and then try to differentiate that, and some So there are many different kinds of way to define AI, and this is one of them to in a very complicated way. So, hey, Sidu, you want to share your definition?
Well, I just typed this into my chat GPT.
Okay.
I said, what is AI? And here is what it says. AI, or artificial intelligence, is the field of computer science focused on creating systems that can perform tasks that normally require human intelligence.
Yeah. Okay. Thanks for sharing. That's a one way to describe it, I should say. Yeah. So this is one way to think about it, right? So this is one of the kind of a chart graph I found online. So AI includes a lot of things. Like you can see that it says, okay, machine learning is a huge part of AI. So the answer from ChatGPT is good, right? So it's trying to replace some of the human intelligence. It's a system that tries to replace human intelligence. And then specifically, you have machine learning, and then computer vision, robotics, reinforcement learning, natural language processing, and then this is a kind of like a big focus right now. I know that's what we're hearing. The deep learning becomes very popular since 2012, and then the generative adversarial networks, and then there are so many things, and we've been recently hearing the most is around Gen AI and large language models. And fundamentally, they are still kind of a part of the, say, deep learning work, and then part of the machine learning, which is part of the AI. So this is too technical, too complicated. We're not going to talk from this language, right? So but what we're going to talk about is a framework that I've been using to help me see through everything, see through the organizations and projects, and then relationships across organizations, and then why teams fail and why teams succeed. So we're going to have a much simpler framework. So this is the first framework. So AI is a combination of coding and math and domain knowledge. So this chart was introduced by one of my managers when I work at Monsanto. It makes a lot of sense to me. So this is back when like data science was very popular. We don't really use AI terminology that often, but use data science. So this is a chart that describes data science. And in kind of if you go back to the previous chart, the AI in this chart is kind of they're trying to uh, almost make artificial intelligence equal to data science. So what I will talk about is that I would just treat data science as AI, or replace this data science by AI. So AI is a combination of hacking skills, math, and domain knowledge. So why are we saying that? So traditionally, when you work on any modeling, like a school, when you work on modeling, or industry, when you work on modeling, so you build some statistical model and solve a business problem. So which is called this traditional research. And once we have the really nice math and stats and plus computer science, so there are a lot of kind of iterative models that have been built through coding and the combination of coding and math stats, right? So a lot of that is not pure, it's not like, you cannot like prove a deep learning model easily. It's a lot of that is actually just coding. So when you combine this two, that's machine learning. And if you just use hacking skills, which is IT, to solve problems, that's the danger zone, which is because you might learn some kind of a random signal and so on. So data science is the combination of the three. And this is very, I'll gradually talk about it, and it's very, very important. It's one of the foundational framework that helped me understand almost everything. So because of this, and another reason is that everyone wants to write themselves in the center, right? So this is how data scientists write themselves in the center. So we are the center, we're the best, right? So and that, but this is a way to help you understand. I've been working with talking to students about this. If you are from IT, if you are engineering school, then you are kind of relatively here. If you have a math and stats, if you're more focused on the theoretical training, then you're on this side. If you're in business school, then you're on this side, right? So you need to improve your skills so that you actually can work on like AI data science. So why is this related to the value creation for organizations? So each area has their own strength. So if you are from like math and stats, and then or in the organization, the data science team, the data analytics team, they can introduce statistical rigor, and then they typically ask questions in a different way because they want to ask in a kind of a quantified approach or statistical way. They can help to remove the noise. Because when they build models, they're going to double check and validate and then cross-validate and see if that whatever conclusions you're getting and validate with new data and see if that actually hold on the new data. So they have their strength. If you're like in the organization, there are like a business branches or so any organization has this substantive expertise, which is also called domain knowledge, then they can ask the right business questions. They know how to prioritize. Usually, they also are responsible for budgeting. If you're from the IT organization, then your school taking engineering school, then you know more about security, scalability, how to support when we develop and deploy certain framework, manage the computation resources, deployment, management, and maintenance, and so on and so forth. So each area has their own strengths. And then because of this, then if you go to the if you have experience working on this project, then you know that there are many different development workflows. So myself, I'm in like the top right? So I've seen from my perspective how everyone is doing the work, right? So the different kind of workflows. For example, so analysts and scientists, they come up with questions, then implement and deploy themselves. So I was like one of them. So I think I got the problem. I know what I'm doing, and so we define the question. Sometimes we validate, sometimes we don't validate with the business, right? So we think this is definitely useful. I'm gonna implement and deploy by myself. Everything is on my local computer. So that's one approach. Business solve questions using Excel manually. So this is also very, very, very common. So most like businesses, if they have like great support, they might have like analytics team to support them. Then they ask a question, then they hand it over to the analytics team. But in many other cases, they have to make decisions so quickly, their data is not like very well organized. I've seen many times like business just solve the questions using Excel, even including some finance team doing the forecast, just using Excel to doing the forecast, and then manually. So that's also a very common workflow. The third workflow is like IT solve questions through rule-based engine. This is also very typical. We have a problem that we're trying to solve, and then we're gonna be basically code it out, right? So, and then when you code it out, then it's typically speaking a lot of rule-based engine. So this is kind of if you go back to the framework there, the three groups of people, if we define data science as a combination of three, and typically speaking, in our organization, these three groups are three different groups of people, and then there is a tendency that each group work by themselves, and I've seen basically many times of each of this workflow happening in organizations. So a little bit better workflows are some of them start to collaborate, right? So for example, business identifies the question, then they ask analysts, scientists to implement, then they work with IT to deploy. It seems like a really nice workflow. Or analysts, scientists identify a question, like ask a business to confirm importance of this question. Analysts, scientists implement, and then they deploy with IT. Or IT comes a question, IT confirms with the business, IT asks analysts, scientists to implement, IT deploy. So you can see that for actually an organization to develop a good solution that is useful, it takes multiple groups of people to work together. And then if we do not do that, then there will be very bad consequences. And that's one of the key reasons that value are not being created. Or in our one of the studies showed that 85% of AI projects at the end failed. And this is one of the key reasons is that either the team is working in silo or they're leveraging the other team's strength. And then there are also more practical reasons that we will discuss a little further later on. Okay. So because of this, then there are very complicated outcomes from this suboptimal workflow. So if you're, for example, if you're analyst, scientist only, okay, implementation was really fast, and then we believe that the model is statistically very rigorous. We know what we're doing, and we're not trying to do anything that's naive or not learning from like a randomness from the data. We always know what we're doing, but then you might be solving the wrong problem. It's really hard to maintain because we're not leveraging the IT solution. You're running the models locally. So I myself made that a mistake. Like example is like you want to build a quick churn prediction model that's built in a notebook and then it's not production ready, right? So business, we talk about it. So the biggest challenge of business is making their own models or conclusion is that they might be taking actions on random or less important signals. I've seen this as well. So in startup world, or any company, industry leaders, the leadership always want to say, okay, churn problem is the biggest problem. Churn problem is the biggest problem. Why is that? Because the investors are concerned about churns. And why is that? Because for startups, churning the actual customer renewing rate is the most important thing. But that's not the case for a more mature organization, a little bit later stage organization anymore. And then in some analysis that we did, actually, we found the loyalty if you actually work on the loyalty part of the problem versus the churn, the value that you can create from loyalty is like 100 times more than churn. But business always ask questions with in many times without actual data to support. So this is the biggest risk that actually the less important projects have been prioritized in the companies. So like IT only, and we also talk about it, it also might be solving the wrong problem or not leveraging AI. I've also seen many companies, many projects I've seen that IT handles that end to end, but even with the little analytics added, it could improve it so much. And then another negative consequence is that once you have a rule-based engine, the rule becomes very complicated. And then the engine becomes complicated at the end. And then it's very hard to manage. And then when the business makes some changes, then you have to maintain that rule. It's very, very, very complicated. But in analytics world or data science world, there are actually much better framework that you can introduce that is very generic and can handle all the rules altogether. It's much simpler. So I'm not going to go through all the combinations, but just want to say that there are, for all the suboptimal workflows, there are consequences. And then either not solving the right problem, solving the problem with less value, or not scalable. And all of those things lead to the kind of the whole project not being delivered, or in a better case, it is the project has been delivered, but you're not really realizing the value. So in addition to that, there are also tensions because of this. For example, the ones that I have received, why is AI working on deployment without talking to us from the IT organization, right? So why is it the science team creating separate database tables? What are they doing with this? How are they managing this? And so on and so forth. And business teams think they know what they're doing, but they do not. So that's a very common negative comment from originally from the analytics or science teams criticizing the business teams. Managing deployment through IT is too slow. I can do it in one day, but they need to do sprint planning because I need to wait for a month. Sometimes they do 2-week sprint. If they cannot get it done within one, then I have to wait for 4 weeks. But if I do it, I can do it in one day. The data science team just claims all the value we're generating. We're not being supported in the right way. So there are a lot of tensions that can happen in this suboptimal world. And it's really the key takeaway actually is that it takes a combination of hacking, statistics, and domain to develop solutions that bring value. Hacking means the IT, and then rigorous engineering practice, statistics, math, and stats, which is the analysts and scientists, and domain, the folks who really understand the business, but might not know exactly the question, how to leverage AI. So it's really the combination of the three to develop AI solution that bring value. So that's the takeaway, first takeaway of the application of the first framework. I just want to pause and see if there are any comments or questions. I really don't know. I cannot see anyone, so I don't know what everyone's thinking. I want to take a pause and see if anyone has any comments or questions. Okay. If not, let me continue. I know it's also lunch time, right? So everyone's having their lunch. Let me continue. So practical applications of the framework. So for IT, build a great data foundation is critical. Typical success comes from adopting some of the cloud solutions. So that's really foundational because it enables other team, like for example, it enables analysts and scientists to access the data in a much better way. And also the data is organized, so we're not spending time just figuring out what data to use and going back and forth. And there's a mess and then multiple things in multiple places, and so on and so forth. And then building using AI to answer questions requires a really nice data set to have. right? So, and that's one of the most important thing. Build scalable deployment workflows, so which is also critical, because you do not want the scientists to manage the deployment on their local computer. So there needs to be a enterprise solution, and adopting some of the MLOps solution, machine learning operations will be also critical. So this is more like in the AI world, good foundation, data foundation is the input. Scalable deployment workflow is more like the output. So for business, it's a kind of a leadership-led project, the prioritization. Another very important thing is you can actually assess AI project value very early, involving analysts and scientists. There are actually some really nice approaches that's available without even spending much time into the projects. Or you can actually estimate using the large language model. Large language model actually does a pretty nice job, decent job of comparing which project might has higher value than the other. For analysts and scientists, then there should be no silo model running on a local machine. Adopt IT best practice, using Git for version control, CI/CD, and so on. Solve the right questions. Always talk to the business and solve the right question, and quantify value rigorously to help the business see the value. So if you have for actually a small organization like us, so we don't have like a separate IT team and business analysts and scientists, right? So, but it's really the practical kind of advice is that you need to have all those components in the organization. If it's very big, then all these three needs to be there. Additional practical applications. So leadership, choose the right org structure. Some prefer to place the analysts under IT. So those, just imagine that the IT becomes like part of that is engineering or data management, and part of that is the data science and analytics, right? So that's one way to do that. Some other also separate and then place the analysts and science under the business vertical. So that's another way to do that. But evaluate the right org, kind of choosing the right org structure that best feeds the organization is very important. As I mentioned, there will be tensions there, and then inefficiency of communication across the teams. And then if you do not have the right talent, then it's really a mess. And if you have some teams that are working in silo in a lot of the projects, then that's even worse. So really leveraging the strengths of each organization is the key. Also define some project review checklist. That's what we usually do. So when I work as director of science, so I try to help the team understand that. Are we taking action on random signals? Are we solving the right questions? Are we developing scalable solutions from day one? That once the framework is developed, actually we're actually solving the actual problem with value quantified, and then we can actually show how much value the AI solution is bringing to the business. And we have already considered the deployment, which is a scalable solution that's compatible with what IT has been doing. Again, another application could be hiring. Early stage companies like hire talent that's on that understand the 2 or 3 areas. For a later stage company, hire what's missing. A lot of this is some of the things I've seen is is that like the organizations I work for, some has a centralized data science organization, like a centralized analytics and science organization to support all the business. But then they also hire analysts and scientists under the business, which could be a problem. In some other case, what I've seen is that they're not hiring the people who truly understand scalable IT solutions. I recently talked to a not very small kind of a consulting firm, and they definitely do not have the right IT folks that understand how to manage their data. So their data is is as of now is still like totally a mess, and then there is like a little chance they can actually build any AI models internally. So they've been focusing a lot on serving their clients, prescribe, kind of telling them what to do, but their internal data structure is very bad. Really kind of focusing on hiring the right talent is very important. Okay, so that's the first one. Any questions, comments? Okay, then let's move on to the second framework that helped me a lot. So AI optimizes decision making. So this is easier to understand than easier to say to actually understand. Here's a kind of a flowchart. It's a very simple way to describe what it means. So business leaders, so they make decisions. And then when you make decisions, there are some decisions that are relatively better, and then there are some decisions that are relatively worse. And this is very critical because this is the foundation to that actually AI can bring value to any organizations. What AI does is that you need to have those decisions that have been made in the past, so that we collect all the data. Some data have good outcome, some data do have not so good outcome. Then AI's job is to learn from the data to make better decisions. And then you can see that going back to the ChatGPT answer of what AI is from C2. So it's trying to replace human intelligence. It's exactly doing that here. When business make decisions, whenever we talk to a business and then challenge them, hey, why do you do this, right? So usually my experience has been that the business knows what they're doing. They know why they are doing something. But that doesn't mean that is the best. What AI does is that it will learn from that intelligence and why they are hitting the good most of the time, and then why they are not hitting the good sometimes, right? So what I've seen is that usually the business can get to like 60%, 70% there, and depending on the individual, if you have like a many decision makers, for example, if you have like when I work at Schnucks, if you have each store has a store manager. If they are making decisions, then some are better, some are worse, right? So, and then you can learn from that. Typically speaking, on average, a good kind of a decision maker can get like 60 to 70%. But then if you apply AI to that, then you can actually achieve the good 80%, sometimes 90% of the time. And that's the value, the delta between you achieve, you actually make good decisions versus bad decisions gives you the value of the project. So it's important because the decisions tied to value, and then AI predicts good decisions. So that's how AI ties to value. This is truly the foundational way of seeing why some projects do not have value and some projects have value. And then this is such a great way to also organize data collection. It touches the actual daily work or every project, the responsibility of IT, analysts, scientists, and business. So here are some examples of learning from good decisions, right? So for example, sales, if you don't have AI, then sales reps guess based on intuition, which leads to prioritize, right? So then they make some good guess, and then they make some bad guess. Some then converted, some didn't, right? And then you can learn from that historical data to predict, okay, what's the likelihood to convert and what actions you can actually take to improve that likelihood. So that's the impact. Marketing, which customer you target. Without AI, if you do it manually, then it's kind of unfocused campaigns. As I mentioned, for a large organization, focusing on churn might be a totally wrong initiative. Even if it looks really nice, because if it's only 1% value of another campaign, then why are you running that, right? So and then what AI does is AI will help you identify the right segments, or even sometimes if you structure it in the right way, you've run many campaigns internally, some successful, some were not so successful. Then learning from that data then can help you prescribe what kind of campaigns are successful, and so on and so forth. Operations, how much inventory to reorder, and that's another one. Customer support, you have some, or you can either do it randomly or first come, first serve, or routes based on the issue type, agent scale. Kind of finance, who should be approved for credit. Sometimes this is also like you're making the decision to approve and not approve, right? So that in the past, then you've collected the data around, if I approve but it didn't work out, if I you probably don't have a lot of, like, if you do not approve, then you do not have the actual data collected, but then you have data in the past of the bad decisions that have been made, as well as the good approval decisions that have been made. Then you can learn from that signal and then see why am I actually making bad decisions. And then you learn from that signal, use that to prescribe what you need to do. So that's how it brings value. So and so on, so on. So it's really like almost every single AI machine learning project that ties to decision making can be actually described in this framework. And it's really very practical as well when you actually use it. So it is it's an easy concept, but usually missed in the business operations. So some common mistakes that I've seen is that they say, I don't have enough data. This is very common. A lot of the business leaders focus on collecting data rather than focusing on, okay, what kind of decisions can I optimize? And then to do that, what data do I need? I don't know if it's possible to do anything. So when I work at Chinook, we had a conversation with a leader, and then he mentioned that he doesn't know whether it's possible to actually know the printed ad. So every week, Chinook designs a printed ad. It's very hard to know week over week which one actually works, which one doesn't, because it is very random, and a lot of the complicated interaction that's there, because usually if you design an ad and then suddenly there's a snow event and then you have a better sales, and then you thought, okay, this is a great ad, right? But then in another week, uh, 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 but then in another week, there's nothing going on. You thought, okay, that we designed so well, but then the sales was not good. Then you think, okay, is this really good or this really bad? So they really don't know whether it's possible to do any of that. No, we did an AI project, but I'm not sure if it actually worked. So that's also very common because it did not originate from decision making. So really should go kind of backward. Okay, I have a decision that I made. I have the data. I collect those data, and then I build a model. My model is to prescribe better decisions. Then you quantify the value and so on. So that's the way to do that. I'm running a campaign, what data to collect? That's also a very common question that's been asked. I don't really know what data to collect, which one might be in the future be useful. So usually it's also missing is that the good or bad, the actual outcomes is always the most important thing to collect. Make sure that the actual outcome is there, then you can always build a model, even if you do not have a lot of data. So to predict, but you at least know whether it's good or bad. Then you can make a prediction. And usually when you make a prediction, it's better than when a human does it, because we'll use the human intelligence as inputs. And then build a model on top of the human intelligence, everything that they've been doing, and then build a model on top of that and improve. How can we apply deep learning? How can we apply large language model? That's another way, is that it is a technical focused with technology focused. I have a technology first, and then to identify the problem. In some cases, this works because it forces the team to think critically about what kind of questions can be asked when there is a new technology. But also, it usually leads to less valuable projects rather than thinking backwards from the decisions. So what does it mean to different groups? For analyst scientists, it means that learning binary prediction is foundational and the most important. That's actually when I ran the data science team. We train each individual to learn the binary prediction because it's so critical. It is the foundation to your understanding of almost everything. And so that's what we do. Kind of prioritize learning what decision to optimize the key. We talk about that when you make decisions, or when you make good decisions, bad decisions, and sometimes this kind of decision making is very complicated. A typical example is that when the grower makes a decision about what product to grow in their field for the next year, and then the immediate outcome is the yield they are going to see next year. But if you want to predict that yield actually is not the outcome that should be measured. Why is that? Because the yield, most of the yield is mostly driven by the weather. So if you are a data scientist analyst, you're working on this problem, you're predicting the yield, then what you're doing is like 60% of your work is you're predicting next year's weather, which is almost impossible. So there is a lot of kind of a details there that what does that mean about the decision? What is actually the outcome of the decision? In that specific case, then we perform a statistical model to remove that weather signal from the output, and that's how we quantify whether it's a good or whether it's a not so good decisions. For business, identify where decisions are being made with varying outcome. This is a critical way to think about it. When there is no varying outcome, then there is no model. When there is varying outcome, then there is value. That's basically the principle here. Going back to that printed ad, because of the varying outcome per week of the traffic it is driving, then there is a value to build a model to optimize that decision. The higher variance you're seeing, then the higher chance you can see a success, because then there is a big value if you apply AI to do that. Yeah. So document learnings from good bad decisions, so that actually later on the business, the actual people who work on the modeling can actually learn from that. IT collecting data with decision outcome is critical. Collecting historical data is also critical. So there are basically this framework can have many applications, but really foundationally it's a decision focused practice, which means that each group should take certain actions. And if we do that, then you can actually realize value. So when almost every project that when I was working as data science later on were deployed, and then we have direct value created. So when I work at Chinook, we actually delivered almost more than 200 million incremental revenue to the business through practicing all this. Because we always start from that, and then without spending anytime we already know the value, and then we have the decisions. We know that is the decisions with varying outcome. Then we build a model, we optimize it, and then we prescribe the actions that the business needs to take, and so on, so on. So that's exactly how it is being built, and we use this approach to choose projects, and then use this approach to prioritize through them, and then. Okay, so one example. Going back to the printed ad, so this is the LD printed ad, right? So I'll walk you through the typical workflow. So we designed this printed ad 3 months ahead. It's so hard to understand what worked, what didn't. It would be great if I can actually compare a Christmas ad versus a Thanksgiving ad or versus a normal week and understand which one actually worked, rather than just thinking Christmas is the best because Christmas have the highest sales. And then this is great because you make decisions with varying outcomes. So AI can help. Let's build some models to help you quantify the value, quantify the actual week-over-week performance. Let's build some models to help you predict what will work. The results look great. I finally know which week by week which one worked and why, and confident know what should be placed there. On this ad. How do you scale this and so on. So it's a typical workflow should look like this, and which would really be a very smooth approach of delivering value for like one specific project. But if you aggregate everything together, it's a great approach also to identify valuable project within the company, prioritize across them, and also leveraging the right resources to do the right thing. Yeah. Okay. So in the beginning, I mentioned this outline, 9 steps generated by ChatGPT of this talk, right? So I mentioned that we're not going to talk about this, but actually they are really nice outline. If you really look at it, it's really good. The I hyped gap, working on really means data as your advantage, garbage in, garbage out, right? So models to decisions, so on and so forth. Yes, we're not talking about this, but we actually have an answer to all of them. So for AI hype gap, so it's really I call that an awareness gap, which is it's not truly that AI doesn't deliver value. It's really when, for example, when for large language model, Gen AI is really right now is mostly driven by the IT organization without actual use case, business use case, or without analysts and scientists to back up from a statistical perspective. And that's why it's not delivering value. It's not because of the AI hype, is because of the execution. Second, what AI working hard really means, it means actually optimize decisions with quantified value. That's my definition. Data is your advantage. Data foundation is critical. And then the real reason is that you do not want analysts, scientists, or anyone who is working on your data just use a very messy data and then go back and forth and then draw wrong conclusions because the data is not well organized. From models to decisions, it should be a reversed order. You should start from decisions and then to models. Improving ROI early, rather than you prove it, you don't need to prove it. You estimate the value before prove it, which is a much better version of proving ROI, spending a few months already, a lot of resources. Of course, you still want to do that if you want to get the ROI as early as possible. Deploying AI that sticks, the scalable deployment, which should always originate from the IT department, can be proposed by other organization, but there should be enterprise management of the either ML ops or certain kind of a stack that supports that. Real world wins, optimized decisions is really a natural win. Of course, there are a lot of examples we can talk about, but all of them are like optimize decisions, optimize the right decisions with high value. Then it is a natural win. You apply the AI roadmap. You prioritize by estimated value, which is the key to actually bringing a ton of value to the organization. Future practical AI. What I wrote here is a large language model automation. We're going to talk a little bit about that in the next 2 slides. Okay, so we talk about a lot, but what about the large language model, Gen AI, right? So how is that compared against what I just talked about? Does that change anything? Here's one chart that shows that percentage of people that believe ChatGPT may eventually replace their job. First one is software engineer and the data analyst, marketing, and so on. So my version of this, I think software development is a very risky part. I think 50% of the coding work can be replaced by AI already. And then I also think I have been running a consulting company, so I think also consulting might be the second to be replaced, or it's not going to be replaced entirely, but it will be like a very big percentage of the work will be replaced. And we'll go anyone who is working on something like coding, like a saw like a code around coding, analytics, even data science. That's like you're just writing some code to achieve something, interacting essentially with text, text meaning the code, right? Then those are risky, yeah. But if you're doing like creative work, like marketing, I don't think that those will come later. So yeah, going back, what about a large language model and Gen AI? So most Gen AI, here's just my opinion. Most Gen AI projects I actually use IT only. I just mentioned that, not three together. That's why it's not really driving value. Most Gen AI projects violate the framework number 2 principle, using AI to predict better decisions. So that's because where most of the projects are just using Gen language model to generate content. It is not prescribing trying to improve a decision that's been made currently. And then because of that, then it's very hard to quantify the value. And then all you can do is like the most valuable projects is more like a chatbot, kind of a chatbot, because those are new capability. And then other than that, all the other ways of using that, you can achieve automation, but then the value you're creating is really not that much. You're saving some time, but the true value always comes from making better decisions at a company. Most Gen AI projects sorry, this is a duplicate. Large language models are great at creating or extracting information from text, images, videos, but not for everything. So it's only a tool that should be evaluated whether it is actually creating the value for the project, not to replace it, not for everything. Yeah, so that's about large language model and Gen AI. So a little bit about what we're doing. So I mentioned that it's really the two frameworks that I have been using to deliver value for business. We are essentially using those two frameworks in what we're doing here. We claim that will help business to see AI value 3 times faster. What we have is a platform that fully automates the predictive model building process. But how we achieve it, we're producing a production-ready pipeline, so we're respecting the IT engineering requirement. We have incorporated automated reasoning to achieve statistical rigor. A lot of the design part was guided by this principle. And then for domain knowledge, we leverage large language models to extract industry knowledge from the model. We also ingested our AI consulting knowledge into that, so that actually it has expert knowledge, hands-on practical experience, as well as the massive knowledge the language model already has. And then we also provide like end-to-end AI model development assistance services. So those are the because of the I was just talking about that you need to ask the right questions, estimate the value at the right time, and so on and so forth. So that's what we do. This is my last slide. I think someone was okay, yeah, there was no question. This is my last slide. I want to see if the room has any questions. Let me actually stop sharing. Give me a second.